Let's solve this circuit using mesh analysis and Kirchhoff voltage law. First, we'll assign clockwise mesh currents, I1 and I2. Then, we'll write the KVL equations step by step to find the current through the 3-ohm resistor. Before we apply Kirchhoff's voltage law, let's identify the two meshes. We'll assume both mesh currents, I1, I2, flow clockwise. Notice that the 1-ohm resistor is shared by both meshes, and we'll use it when writing our KVL equation. Now let's apply Kirchhoff's voltage law to mesh 1. We start with the 5-volt source, then subtract the voltage drops across the 3-ohm resistor and the shared 1-ohm resistor. After simplifying, we get our first mesh equation. Now we'll solve the two equations together. From equation 2, we get I1 equals 9I2. Substituting this into equation 1 and simplifying gives us I2 equals 1/7 of an ampere. Now let's apply Kirchhoff's voltage law to mesh 2. We subtract the voltage drops across the 6-ohm resistor, the 2-ohm resistor, and the shared 1-ohm resistor. After simplifying, we obtain our second mesh equation. And that's our final answer. The current through the 3-ohm resistor is simply mesh current I1, which equals 1.286 amperes. Great job. Keep practicing, and I'll see you in the next lesson. Excellent work today. You learned how to solve a simple circuit using Kirchhoff voltage law, step by step. Keep practicing to build your confidence. If you enjoyed this lesson, don't forget to like, subscribe, and join me for more exciting electrical engineering tutorials. See you in the next lesson.
The adventure isn't over yet. Subscribe to MindSpark Tunes for more amazing stories, history, and learning adventures. See you next time.